going to discuss some important questions on Unit 2. Myself, Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering in Aeronautical. So first question, we will discuss what is the capacitance between the parallel plate when they are separated by a single dielectric medium. So we know what is a capacitor. We can see here you can see this is the one and this is the down. This is the blue one. This is the dielectric D. These are the conductive plates. So we can write capacitance is the ratio of stored energy Q and the voltage across the plates or the potential difference between two plates V. So what is the equation? The equation capacitance C is equal to Q by V. What is the E? E equals to, we know, Q by epsilon A. How we can this? We can get this E is equal to field intensity is equal to Q by epsilon into A. We know from the Gauss law D, flux density D is equal to, what is flux density D? Flux density D is nothing but the epsilon into E. So what is the E? E is equal to D by epsilon, and according to the Gauss law, the flux in a flux, and what is the flux? Electric flux psi is equal to, what is electric flux psi? Electric flux psi is equal to D by A. So we can write the electric field E is equal to psi by A. What is voltage? Voltage is equal to E into D. So we can write it Q D by epsilon A. Q D by epsilon A. So what is C? C is equal to, we know what is capacitance. According to the definition, C is equal to Q by V. So if we put the value, we can get C is equal to epsilon A by D is equal to epsilon naught epsilon R A by D. This is the capacitance. Epsilon R epsilon A by D is equal to the capacitance. Next, we will discuss the Ohm's law in the point form. First, what is the Ohm's law? When pressure, temperature and other pressure, temperature and other physical activities are constant, we know the current flowing through a conductor is equal to the voltage, is the directly proportional to the voltage. So under the electric field, free electrons start moving, and after some time it attains a constant velocity. The velocity is known as the drift velocity Vd. So under the electric field, free electrons start moving, and after some time it attains a constant velocity. This velocity is known as the drift velocity Vd. So if we increase the electric field strength, the drift velocity will also increase, and we can write Vd is directly proportional to the electric field intensity E. So Vd is equal to mu into E. Mu is equal to mobility constant. Again, we know current density J is equal to rho V into Vd. Current density rho V is equal to, what is rho? How we can get this? We know current density J is equal to dq di by ds. Current plus unit. And what is I? We know that J is equal to, what is J? J is equal to di by ds. What is I? I is equal to, again, d by ds is into bracket dq by dt. dq by dt. di by ds is equal to dq by dt. Now, what is the value of the dq by dt? Again, dq is equal to rho v into volume. So if we put all the value, we will get current density J is equal to rho v into Vd. So rho v is the volume charge density. So in the place of Vd, we can write rho v is equal to minus mu into E is equal to minus rho v mu E. Rho v into mu is equal to sigma E. J is equal to sigma E, where sigma is equal to rho v into mu is equal to conductivity of the conductor. And J is equal to sigma E is known as the Ohm's law in point form. State and derive the expression for equation of continuity. So continuity equation is basically two types, integral form and point form. First we take the integral form. Q is the charge in a closed surface. Let Q is the charge in a closed surface. So we can write current I is equal to dq by dt. Current I is equal to d minus dq by dt. Why minus? Because the direction of current is always opposite to the rate of change of flux. Current density J is equal to di by ds. So I is equal to integration of J ds. So if we equate this, I is equal to integration of J ds is equal to minus dq by dt. This is the continuity equation in the integral form. Integration of current density into ds is equal to rate of change of charge is the continuity of the current equation. Now we will discuss the divergence form. We just got that J dot ds. If we use the divergence theorem, we got J dot ds is equal to grad J dV. Again, we know I is equal to J ds. So if we equate these two equations, we can write I is equal to grad J dV. Again, what is current? Current is equal to I is equal to minus dq by dt. So minus dq by dt is equal to grad J into dV. Grad J into dV. What is Q? Q is equal to rho v into V. What is Q? Q is equal to rho v into V. So we can write Q is equal to integration of rho v into dV. So minus d of rho v dV by dt is equal to grad J. So if we equate these two equations, we got grad rho v del rho v by dt. Why del? Because rho v is a three-dimensional. So del rho v by dt into dv is equal to grad J dV. So if we equate the two equations, we got grad J is equal to rho v into dV. This will be not there. Grad J is equal to del rho v by del t. This is the continuity equation in the point form. Now we will discuss one problem. A conductor wire of diameter 1 mm and conductivity of 5 into 10 to the power 7 ohm per meter has the 10 to the power 29 free electrons per meter cube. When electric field 10 meter per volt is applied, determine the charge density, determine the current density and the current in the wire. So charge of one electron is 1.6 into 10 to the power minus 19. So number of electron is 10 to the power 29. It is given number of electron is 10 to the power 29. So what is the total charge density? Minus 1.6 into 10 to the power 29 minus 1.6 into minus 1.6 into 10 to the power minus 19 into 10 to the power 20. If we put, we will get 1.6 into 10 to the power 10. What will be the unit? The unit will be coulomb per meter cube. What is the current density? Current density J is equal to sigma E. What is sigma? 5 into 10 to the power 7 ohm per meter. What is sigma? Sigma is equal to 5 into 10 to the power 7 ohm per meter. What is E? E is equal to 10 millivolt per meter. If we put the value, we will get the calculation of current. And what is current? Current I is equal to J into S. What is J? J is equal to current density. S is equal to surface density. S is equal to Pi into R square. What is S? S is equal to Pi into R square. So if we put the value, we will get the calculation. Next is the series and shunt connection of the capacitance. What is series connection and what is shunt connection of a capacitance? So if you can see, there are some capacitance, they are connected in series, and C total is equal to 1 by C1 plus 1 by C2 plus 1 by Cn. This is the series connection. If the n number of capacitance are connected in parallel, the C total is equal to C1 plus C2 plus C3 up to Cn. This is the equation for the shunt connection or the parallel connection of the capacitor. It is just opposite to the connection of the resistance. Now on small problem, calculate the capacitance of a parallel plate capacitor with the following details. Plate area is 100 centimeter square. The plate area, this plate and the down plate area is 100 centimeter square. The dielectric epsilon R1 is equal to 3. D1 is equal to 3 millimeter. Epsilon R2 is equal to 4 and D2 is equal to 4 millimeter. If the 220 volt is applied across the plates, what will be the voltage gradient across each dielectric? How to get the equation? A is equal to 100 into 10 to the power minus 4 meter square. What is D1? D1 is given as the 3 millimeter. What is D2? D2 is given as the 0.004 meter. So what is capacitance? Capacitance is equal to C1 is equal to epsilon A by D, or epsilon, we can write D by A by epsilon. What is the value of the D? What is the capacitance? Epsilon A by D, or A by D by epsilon. What is A? A is 100 centimeter square, or 100 into 10 to the power minus 4 meter square. What is the value of the D? D is 0.003. 0.003. What is C1? C1 is 3 into 8.854 into 10 to the power minus 12. And if we solve it, we will get 8.854 into 10 to the power minus 11, and the unit is farad. Similarly, if we calculate the C2, we will get the value of the C2 also. Same formula, 100 in, because cross sectional area is same, 100 into 10 to the power minus 4 by 0.004 by 4 into 8.854 into 10 to the power minus 12. So we got C2. Now you can see that if we connect the battery with this, if we connect one battery with this, both the capacitors are in the series connection. So series connection means C1 into C2 by C1 and C2, and we got the capacitance value 4.42 farad. So we got the capacitance. We have one more part. What will be the voltage gradient across each dielectric? So how to get? We got the charge. If we got the C, we know the voltage. So what is Q? Q is equal to, what is Q? Q is equal to C by V. Q is equal to C by V. What is the value of C? We got 4.4.2. What is V? V is nothing but the 200. So we got here the charge. So as the charge remains constant for the both plates, as we can see, the charge is constant for the both. Charge is constant for the both dielectrics. We can write C1 is equal to Q by V1, and where C2 is equal to Q by V2. If the total voltage is 220 volt, we can get the value of C1 and C2. So what is the potential gradient? V1 by D1 and V2 by D2. V1 value we got, D1 value we know, V2 value we got, D2 value we know. We got the potential gradient. Predict question number 2. Second question number 2. Predict the capacitance of a capacitor of two parallel plates 30 centimeter and into 30 centimeter. So what is the area? Area is 30 into 30 means 910 to the power 4 minus 4 centimeter square. Separated by air in 5 millimeter. 5 millimeter means the distance is 0.005. Calculate the energy stored in the capacitor if it is charged to a potential difference of 500 volt. So what is the capacitance? Capacitance is epsilon A by D. If we put the value 900 into 10 to the power minus 4 into 8.854 into 10 to the power minus 4 divided by 5 into 10 to the power minus 5. If we put the value, we will get 16 into 10 to the power minus 11 farad. So this is the capacitance, 1.6 picofarad. So what is the energy? Energy formula is for a capacitance. What is the energy formula? Half C V square. What is the value of C? C value we have given from this equation. What is V? V is given 500 volt. So if we put the value, we will get. Remember, the energy unit is always in the joule. So we got the equation. First we will calculate the capacitance, and energy stored in a capacitance is half C V square. Next. We have a next question. A cylindrical capacitor having a length of 8 cm is made of two concentric rings with an inner radius of 3 cm and outer radius of 6 cm. Find the capacitance of the capacitor. So what is the total length? The total length is given as the 8 cm. What is the total length? The total length is given as the 8 cm. What is the inner radius? Inner radius is 3 cm. What is the outer radius? Outer radius is the 6 cm. And what is the formula? The formula C is equal to 2 pi epsilon naught L ln B by A. So 2 pi epsilon naught means 8.854 into 10 to the power minus 12 ln B by A. What is B? B is the outer radius, which is 6 cm. What is the meaning of 6 cm? 0.06 meter. What is the inner radius? Inner radius is 3 cm and 3 cm means 0.03 meter. So what is the capacitance? 2 pi epsilon L. L is the total length and total length is 8 cm and 8 cm means 0.08 meter. So what is the capacitance? 1.447 into 10 to the power minus 11 farad. So we got the capacitance for a coaxial capacitor. So the parallel plate of a spherical capacitor have a radii of 38 mm and 40 mm. Calculate the capacitance. What must be the plate area of capacitor with the same plate separations? So this is the next question. We have to calculate the parallel plates of a spherical capacitor with a radii of 38 meter and 40 millimeter and calculate the capacitance. So what is the formula? C is equal to 4 pi epsilon naught AB B minus A. 4 pi epsilon naught AB. A is 38 and what is the B? B is 40. So if we put the value, we will get the capacitance value is 84.5 picofarad. What will be the capacitance? So we know the capacitance C is equal to epsilon A by D. What is capacitance? Capacitance value we got from here 84.5 picofarad. We have to calculate the D. What is A? A is also, what is D? D is basically the distance between these two parallel plates. So what is the distance? The distance is 40 minus 38 means it is the 2 millimeter. It is the 2 millimeter. Epsilon value we know, capacitance value we know. From there we can calculate the A. So what is capacitance A? A is equal to C into D by epsilon. And if we put the value, we can calculate the capacitance of a spherical capacitor. Write the boundary conditions between a conductor and the free space. So when an electric flux passes from one medium to another medium, their characteristics changes. The condition of existing boundary is known as the boundary conditions. Before discussing the boundary condition, we have some assumptions. Field intensity, and we will assume that the field intensity and flux density inside a conductor is 0. The charge only appears on the surface. The charge density within the conductor is 0. So we can see this is a conductor portion, this is the boundary, and the outer side is the air. So this is the conductor, this is the free space. So if we discuss about this, there is some E can be dissolved into two parts. One is the E tangential part, here it is shown in the green color. Another one is the normal part, which is shown in the orange color. So it has the two components. The green component is the tangential and the blue one is the. Now if this is the EMF, we can divide the EMF into 4 parts. One is the AB, you can see from here. First is the EAB, means A to B. Here the brown one is showing A to B. Then B to C, integration of B to C. Then C to D, and then D to A, So we can calculate, and here you can see that CD is inside the conductor, so it is 0. We will take the integration of A to B, B to C, and D to A. Is equal to 0, as according to the assumptions the power inside the conductor is equal to 0, so we are not taking it into the account. Now you can also see the half portion is also 0, so the integration will be from A to B, B to 2, and 1 to A, because the lower portion is inside the conductor, and again the intensity is 0 in the inside of the conductor. So our integration will be changed into the A to B, B to 2, A to 1. Again, B to 2 is downwards direction and 1 to A is the upward direction, and both are the same magnitude. So both will cancel each other. So our main is the integration. So these two will be cancel each other. So our main integration is A to B E dot dl is equal to 0. So if we think we are coming to this, E to dl is equal to AB is parallel to the tangential component, so we can write E tan, and the width is W, so E dot dl is equal to E tan into delta W is equal to 0. So this is the main equation for a continuity equation. Define the dipole moment and deduce its expression. A dipole results from the displacement of the charge and the dielectric is said to be polarized. In the polarized state, the electron cloud is distorted by applied electric field E, and the distorted charge distribution is equivalent by the principle of superposition to the original distribution plus a dipole whose moment is P is equal to QD. So we can write P is equal to limit V tends to 0, V is the volume tends to 0, K is equal to 1 to N, QK dk by del V. So this is the dipole moment. A dipole moment, what is electric dipole? An electric dipole is formed when 2 point charges of equal magnitude and opposite signs are separated by a small distance. When an electric field E is applied, the positive charge is displaced from equilibrium position in the direction of E. So A plus is equal to QE and F minus is equal to QE. And if the two opposite charges are separated by a distance d, the polarization can be told as the distance traveled by the point charge is defined as the dipole moment, and dipole moment is the product of the charge q and the distance traveled by it d. And we can write the line is known as the axis of dipole. This equation is known as the axis of dipole. So we have discussed the dipole moment. Extract the expression for torque on an electric dipole in an electric field. So you can see this is a plus q and minus q which has make an angle theta. The experienced is F1 is equal to EQ and the experienced by minus q is equal to F2 is equal to minus EQ. So the total force is equal to 0. But due to the force experienced by plus q, it will, and minus q, there is a chance to oscillate and come in the zeroth position, which leads to the torque of the dipole. So dipole the torque can be defined as the magnitude of F and perpendicular distance between their line of action. So what is the value? This is if this length is r and this is a triangle like this r. If this is the 2r, because from midpoint we are taking r, so the total length is r, 2r. So what is the distance? The distance if the angle is theta, so we know it is the 2r sin theta. So we can write here EQ into 2r sin theta. Again Q into 2r can be written as the P. So we can write it as PE sin theta, where P is the dipole moment, E is the intensity, sin theta is the angle. So we can calculate the torque on the PE sin theta. So up to this is today's session. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.